What are we going to do? I know how to multiply fractions, but adding fractions? Oh. Well, let's think about what fractions actually are. They're divisions, right? Division leads to a number. Let's write those divisions down. 11 divided by 15, and that one is 2 divided by 15. Okay, I'll buy that. What are we going to do with that? The distributive property, remember that? We're dividing by the same number in both cases. We can use the distributive property. Here, check it out. All right, we can write this divided by 15 as multiplying by 1 over 15. Same thing over here. Now, we could have just seen this right from, fraction multiplication. 11 times 1/15, that's 11/15. 2 times 1/15, it's 2/15. And now we can factor out the 1/15. We're just using the distributive property. This will be 11 plus 2 times 1 over 15. Now, of course, when we multiply these out, 11 plus 2, that sum times 1, that's just 11 plus 2. So you get 11 plus 2 over 15. And, of course, that's just 13 over 15. Check that out. All we did was add the numerators. Just keep the denominator the same. We get 11 plus 2, all that over 15. Hey, maybe we can do that to add any two fractions. Let's try that out. So let's see. Our first step before was, we're going to try the distributive property. We'll write this as a times 1 over c plus b times 1 over d. Uh-oh. I can't use a distributive property here. I can't factor anything out. 1 over... What did we do back there? Why were we able to factor out here? The denominators are the same. That's the key here. So maybe it's when you add two fractions and the denominators are the same, you just add the tops. Let's check that out. Here we go. So we got two fractions here with the same denominator. They both have c as the denominator. Let's see if we can add these by just adding the numerators. So a over c, that's just a times 1 over c. And b over c, that's just b times 1 over c. It worked. Of course it worked. Now we can use the distributive property. We can factor the 1 over c out. And we get a plus b times 1 over c. That worked. Now when we multiply these two, we just multiply a plus b times the numerator there. Multiply something by 1, you get that thing back. So this just becomes a plus b over c. And sure enough, any two fractions, they have the same denominators. We can add them just by adding up the numerators. We get a plus b over c. So that takes care of addition. You know what's next. Subtraction. Hey, maybe we can do the same thing here. Let's try that. Try this. This is just 14 times 1 over 3 minus 2 times 1 over 3. Sure enough, we can factor out the 1/3. We can factor this out and write this as 14 minus 2 times 1 over 3. And we multiply the 14 minus 2 and the 1. We'll just get the 14 minus 2. And we'll have 14 minus 2 over 3. And check that out. 14 over 3 minus 2 over 3. It's just 14 minus 2 over 3. And if we look back at this, we can go through and replace all the plus signs with minus signs. Turn that into a minus, that into a minus, that into a minus, that into a minus. And we see that if we subtract two fractions that have the same denominator, all we do is take the first numerator minus the second numerator, and the denominator stays the same. That's all we have to do to subtract two fractions. Of course, 14 minus 2 is 12. 12 over 3, that is 4. So check this out. Add two fractions with the same denominator. Keep the denominator the same. We add the numerators. And we proved it right here. We can go through and replace all these pluses with minuses to see that to subtract one fraction from another when the two denominators are the same, all we do is subtract the numerators and keep the denominator the same. But what if the denominators in the original fractions are different? Then what do we do?